Hello students, in the previous session we discussed about parabola and the definitions related to it. In this session we shall solve some problems to understand the concepts. Here we have type 1 examples on finding the equation of a hyperbola when its focus, directrix and eccentricity are given. So, here is an example. Find the equation of the hyperbola whose directrix is 2x plus y is equal to 1, focus 1 comma 2 and eccentricity is square root 3. Look into the solution. Let S 1 comma 2 be the focus and point P x comma y be a point on the hyperbola. Draw PM perpendicular from P on the directrix. Then SP is equal to E into PM, that is by definition. Now, using distance formula we have square root of x minus 1 whole square plus y minus 2 whole square is equal to root 3 into 2x plus 1 minus 1 upon square root of 2 square plus 1 square. On simplification we have x minus 1 whole square plus y minus 2 whole square is equal to 3 into 2x plus y minus 1 whole square divided by 5. On simplification we have 5 into x minus 1 whole square plus y minus 2 whole square is equal to 3 into 2x plus y minus 1 whole square. On solving we have 7x square minus 2y square plus 12xy minus 2x plus 14y minus 22 is equal to 0, which is the required equation of the hyperbola. Here we have another example of type 2 on finding the center, lengths of transverse and conjugate axis, eccentricity, foci vertices, latus rectum, directrices, etc. of a given hyperbola. Here goes the example. For the following hyperbola, find the length of the transverse and conjugate axis, eccentricity and coordinates of foci and vertices, length of the latus rectum, equation of the directrix 16x square minus 9 square is equal to 144. For the solution, we can see here this is of the form x square upon a square minus y square upon b square is equal to 1, where a square is equal to 9, b square is equal to 16. Now, length of the transverse axis here is 2a, that is equal to 6. Similarly, the length of the conjugate axis is 2b, that is equal to 8. Eccentricity E is given by square root of 1 plus b square upon a square, that is square root of 1 plus 16 upon 9, which on simplification gives us 5 upon 3. Foci can be calculated here. The coordinates of the foci are plus or minus a e comma 0, that is plus or minus 5 comma 0. The coordinates of the vertices are plus or minus a comma 0, that is plus or minus 3 comma 0. Latus rectum, the length of the latus rectum is equal to 2b square upon a, that is 32 upon 3. The equations of the directrices are x is equal to plus or minus a upon e, that is x is equal to plus or minus 9 upon 5. Let us solve one more example here. Show that the equation 9x square minus 16y square minus 18x plus 32y minus 151 is equal to 0 represents a hyperbola. Find the coordinates of the center, lengths of the axes, eccentricity, latus rectum, coordinates of foci and vertices, equations of the directrices of the hyperbola. In the solution we have here 9x square minus 16y square minus 18x plus 32y minus 151 is equal to 0, which can be written as 9 into x square minus 2x minus 16 into y square minus 2y is equal to 151. which can be again written as 9 into x square minus 2x plus 1 minus 16 into y square minus 2y plus 1 is equal to 151 plus 9 minus 16, which can be further simplified as 9 into x minus 1 square minus 16 into y minus 1 whole square is equal to 144, which can be expressed as x minus 1 whole square upon 16 minus y minus 1 whole square upon 9 is equal to 1. Take this equation number as 1. Shifting the origin at 1, 1 without rotating the axis, denoting the new coordinates of with respect to these axes by x and y, we obtain x is equal to x plus 1 and y is equal to y plus 1. Take this as equation number 2. Using these relations, equation 1 reduces to x square upon 16 minus y square upon 9 is equal to 1. Take this as equation number 3. This is of the form x square upon a square minus y square upon b square is equal to 1, where a square is equal to 16 and b square is equal to 9. Center can be calculated as the coordinates of the center with respect to the new axis are x is equal to 0 and y is equal to 0. So, the coordinates of the center with respect to the old axis are 1, 1, putting x is equal to 0 and y is equal to 0 in second equation. Transverse axis, length of the transverse axis is equal to 2a, that is equal to 8. Conjugate axis, length of the conjugate axis 2b is equal to 6. Eccentricity E is given by E is equal to square root of 1 plus b square upon a square, that is equal to square root of 1 plus 9 upon 16, which on simplification gives us 5 upon 4. Lattice rectum, the length of the lattice rectum is equal to 2b square upon a, that is equal to 18 upon 4, which can be simplified as 9 upon 2. Foci, the coordinates of the foci with respect to the new axis are x is equal to plus or minus a e and y is equal to 0, that is x is equal to plus or minus 5 and y is equal to 0. So, the coordinates of the foci with respect to the old axis are 1 plus or minus 5, 1, that is 6, 1 and minus 4, 1. This we have obtained by putting x is equal to plus or minus 5 and y is equal to 0 in equation number 2. Now, look, how do we calculate the vertices? The coordinates of the vertices with respect to the new axis are x is equal to plus or minus a and y is equal to 0, that is x is equal to plus or minus 4, y is equal to 0. So, the coordinates of the vertices with respect to the old axis are plus or minus 4 plus 1, 1, that is 5, 1 and minus 3, 1. This we have obtained by putting x is equal to plus or minus 4 and y is equal to 0 in second equation. For the directrices, the equations of the directrices with respect to the new axis are x is equal to plus or minus a upon e, that is x is equal to plus or minus 16 upon 5. So, the equations of the directrices with respect to the old axis are x is equal to plus or minus 16 upon 5 plus 1. This we have obtained by putting x is equal to plus or minus 16 upon 5 in second equation, or x is equal to 21 upon 5 and x is equal to minus 11 upon 5. Now, let us look into another type of examples here on finding the equation of a hyperbola when some of its parts are given. Here goes the example. Find the equation of the hyperbola referred to its principal axis as axis of coordinates in the following case: vertices at plus or minus 5, 0, foci at plus or minus 7, 0. Let us look into the solution. Since the vertices lies on x axis, so let the equation of the required hyperbola be x square upon a square minus y square upon b square is equal to 1. The coordinates of its vertices and foci are plus or minus a comma 0 and plus or minus a e comma 0 respectively. But the coordinates of vertices and foci are given as plus or minus 5 comma 0 and plus or minus 7 comma 0 respectively. Therefore, a is equal to 5 and a e is equal to 7 and e is equal to 7 upon 5. B square is equal to a square into e square minus 1, which can be expressed as b square is equal to 25 into 49 upon 25 minus 1, which on simplification gives us 24. Substituting the values of a square and b square in 1, we obtain x square upon 25 minus y square upon 24 is equal to 1 as the equation of the required hyperbola. Here we have another example. Find the equation of the hyperbola, the length of whose latus rectum is 8 and eccentricity is 3 square root 5. Let us see its solution. Let the equation of the hyperbola be x square upon a square minus y square upon b square is equal to 1. The length of its latus rectum is 2b square upon a. It is given that the length of its latus rectum is 8. Therefore, 2b square upon a is equal to 8, which gives us b square is equal to 4a into e square minus 1 is equal to 4, that can be simplified as a into 9 upon 5 minus 1 is equal to 4. On simplification, we get a is equal to 5. Putting a is equal to 5 in b square is equal to 4a, we get b square is equal to 20. Substituting the values of a and b in equation number 1, we obtain x square upon 25 minus y square upon 20 is equal to 1 as the required equation of the hyperbola. Here we have one more example for you. Find the equation of the hyperbola whose conjugate axis is 5 and the distance between the foci is 13. Let 2a and 2b be the transverse and conjugate axis and e be the eccentricity. Let the center be the origin and the transverse and the conjugate axis the coordinate axis. Then the equation of the hyperbola is x square upon a square minus y square upon b square is equal to 1. We have 2b is equal to 5 and 2a is equal to 13. Now, b square is equal to a square into e square minus 1, which gives us b square is equal to a square e square minus a square, that is 25 upon 4 is equal to 169 upon 4 minus a square, which gives us a square is equal to 144 upon 4, that is a is equal to 6. Substituting the values of a and b in equation number 1, the equation of the hyperbola is x square upon 36 minus y square upon 25 upon 4 is equal to 1, which gives us 25 x square minus 144 y square is equal to 900. Here we have a very interesting problem on hyperbola of type 4. The example is, if E and E dash be the eccentricities of a hyperbola and its conjugate, prove that 1 upon E square plus 1 upon E dash square is equal to 1. Look into the solution. Let the equation of the hyperbola be x square upon a square minus y square upon b square is equal to 1. Take this as equation number 1. Then the equation of the hyperbola conjugate to this is x square upon a square minus y square upon b square is equal to minus 1. Take this as equation number 2. Now, E is equal to eccentricity of 1, that is equal to square root of 1 plus conjugate axis upon transverse axis whole square. E is equal to square root of 1 plus 2b upon 2a whole square, that is E square is equal to 1 plus b square upon a square, and E square can be written as a square plus b square upon a square. Take this as equation number 3, and E dash is equal to eccentricity of second equation, that is equal to square root of 1 plus conjugate axis upon transverse axis whole square. Therefore, E dash is equal to square root of 1 plus 2a upon 2b whole square. On squaring, we have E dash square is equal to 1 plus a square upon b square, that is E dash square is equal to a square plus b square upon b square. Take this as equation number 4. From equation number 3 and 4, we have 1 upon E square plus 1 upon E dash square is equal to a square upon a square plus b square plus b square upon a square plus b square is equal to 1. Now, students, let us summarize the points which we have studied in this topic, that is hyperbola. Our first point was a hyperbola is the locus of a point in a plane which moves in such a way that the ratio of its distance from a fixed point called focus in the same plane to its distance from a fixed line called directrix is always constant, which is always greater than unity. The fixed point is called the focus, the fixed line is called the directrix, and the constant ratio generally denoted by E is known as the eccentricity of the hyperbola. The general equation of the hyperbola is of the form a x square plus 2h x y plus b y square plus 2 g x plus 2 f y plus c is equal to 0, when a b c plus 2 f g h minus a f square minus b g square minus c h square is not equal to 0, and h square is greater than a b. Another important point we noted was a hyperbola whose transverse and conjugate axes are respectively the conjugate and transverse axis of a given hyperbola is called the conjugate hyperbola of the given hyperbola. Yet another point to be noted is, if the center of the hyperbola is at the point h comma k and the directions of the axis are parallel to the coordinate axis, then its equation is x minus h whole square upon a square minus y minus k whole square upon b square is equal to 1. So, students, in this session we discussed about hyperbola and we solved so many examples. In the next session, we shall discuss about ellipses. Thank you.